One of the most anticipated astronomical events is the Betelgeuse supernova located on the famous shoulder of Orion. Betelgeuse is a red supergiant star nearing the conclusion of its life. Strangely, in 2019, Betelgeuse, one of the brightest stars in the sky, began to fade. The fading was so noticeable that it could be seen even without special optics. For a few months, Betelgeuse dimmed until observers began to wonder if the star had died. When scientists focused their most powerful telescopes on the red giant star, they were shocked to see evidence of the great dimming even though the star's brightness had returned to normal after a few months. This star is about to blow up as its life cycle comes to an end. When and why might a supernova happen, and will it have disastrous consequences for Earth? Let's look into it. The brilliant ruby-red star Betelgeuse is located in the upper right shoulder of the winter constellation Orion the Hunter. You may know it better by its alternative name Alpha Orionis, but it is the second brightest star in the constellation directly behind the blue supergiant Rigel. Betelgeuse is an interesting target for astronomers to observe and study because of its variable behavior and peculiar name. Alpha stars are usually the brightest in their constellations, and this is true even though Rigel, Orion's other great star, is brighter. Due to its name, brightness, size, and reddish color, Betelgeuse, also known as Alpha Orionis, is one of the most famous stars in the sky. It is the 10th brightest star in the sky and the 7th brightest star visible from most of North America, Europe, and Canada. Betelgeuse comes from an Arabic word that means the armpit of the giant, which is a frequent interpretation of the name. Betelgeuse's actual distance from Earth is unknown. However, scientists believe it to be anywhere from 430 to 724 light-years. To put it simply, Betelgeuse is the brightest and closest red supergiant star to Earth. There are just about 200 red giant superstars known to exist in the Milky Way. Betelgeuse is 16 times the size of the Sun, emits 126,000 times as much light as the Sun, and is visible from a distance of 548 light-years. It is cooler than the Sun, with a surface temperature of 3,600 Kelvin. Around Betelgeuse, just about 13% of its total radiant energy is made up of visible light. Betelgeuse would be more luminous than Sirius if we could perceive light at all wavelengths. It is estimated that Betelgeuse is around 764 times the Sun's radius in diameter. If this star were to take over as the sun of our solar system, its influence would extend past Jupiter and the asteroids. This would result in the complete engulfment of Earth, Mars, Mercury, and Venus. Betelgeuse, a red star, loses about 1 solar mass every 10,000 years as material is ejected unevenly from the star in all directions, resulting in a nebula surrounding the red star. The nebula surrounding Betelgeuse is roughly 30 astronomical units, AU, or 30 times the distance between the Sun and Earth, and it is 250 times larger than the star itself. At its center, a star's hydrogen atoms fuse together under the influence of gravity, producing helium in a nuclear explosion. Heat and light are two forms of energy that are often released in abundance during the fusion process. This vitality makes its way to the surface of the star, where it is eventually discharged as a photon into the cosmos. Eventually, the star will run out of its primary fuel, hydrogen, and will have to rely on helium and carbon for combustion. When all the helium has been consumed, neon will react with carbon to produce iron. When this occurs, the energy released by the fusion of neon and iron is absorbed. As iron begins to burn within the star, its high gravity causes it to collapse in on itself, triggering a supernova explosion powering 10 billion suns. A supernova is one of nature's most powerful explosions. Depending on their age and evolutionary stage, stars emit light of varying wavelengths and temperatures, resulting in a spectrum of colors from the blue of the youngest stars to the red of the oldest. According to Ptolemy, a Greek scholar who lived from 90 to 168 AD, Betelgeuse's color was oddly described as ruddiness. However, ancient Chinese astronomers noted that Betelgeuse appeared yellow, suggesting that it may have been a yellow supergiant in the past. Larger stars often burn through their hydrogen fuel more quickly, leading to their eventual demise even if they are just roughly 10 million years old. Unquestionably, Betelgeuse is in its latter stages of existence. However, at over 5 billion years old, our sun is still going strong. The star Betelgeuse is nearing the end of its existence, which means it may go supernova at some point. However, the exact timing of this occurrence is hotly contested. There are two cycles of dimming and brightening that occur on Betelgeuse, the second of which occurs every 5 years and lasts for about 100 days. There's an assumption that the star's outer shell expands and contracts over this cycle, causing the star's diameter and average temperature to change at each stage. A lot of people paid attention to Betelgeuse because of its erratic dimming in 2019 and 2020, followed by a temporary recovery to its usual brilliance. Some astronomers have speculated that it could mean the star is dying. Extensive study of Betelgeuse dates back to the 1st century BCE. Nonetheless, the cause of its sudden and atypical waning remains unknown. Betelgeuse was detected speeding across the interstellar medium at a rate of 30 kilometers per second after being ejected from its home in the Orion OB1 association, which contains the stars in Orion's belt. Bow shock from this speeding star spans over 4 light-years across. Distances to red supergiant stars like Betelgeuse are notoriously difficult to calculate in astronomy. Many factors make it hard to calculate Betelgeuse's real diameter. The star of Betelgeuse changes over time since it's a pulsing star. As a result of limb darkening, the star's visual emissions change color and fade away as one moves away from its center. When trying to define Betelgeuse's photosphere, it's important to account for the circumstellar envelope, which is made up of material emitted from the star and emits and absorbs light. It's tricky to make direct comparisons between observations due to the star's apparent size changing with wavelength. Diameters can vary by as much as 35% depending on the wavelength used to measure them within the electromagnetic spectrum. In July 2009, the European Southern Observatory released images taken by the ground-based Very Large Telescope Interferometer, VLTI, which showed a gigantic gas plume extending $30 from the star into the surrounding atmosphere. One of multiple mass ejections from Betelgeuse's atmosphere, this one had a magnitude equal to the angular separation of the Sun and Neptune. At least 6 shells have been discovered by astronomers circling Betelgeuse. If the enigma of mass loss in the dying stages of a star's life could be answered, perhaps the cause of these stellar giants' tragic demise could be found. Betelgeuse's long atmosphere and its intricate dynamics have been questioned in addition to the star's diameter. The exact mechanism by which the material is lost from red supergiants is a mystery, yet they are crucial to the recycling of matter that forms galaxies. Thanks to recent developments in interferometric techniques, astronomers may soon find a solution to this conundrum. Researchers utilized Hubble and other telescopes to discover that in 2019, the star rejected a large chunk of its visible surface and produced a major surface mass ejection, SME. Coronal mass ejections, CMEs, occur often when the Sun expels chunks of its tenuous outer atmosphere, the corona. The intensity of these events is thousands of times lower than what was observed on Betelgeuse. The surface mass ejection from Betelgeuse expelled 400 billion times more mass than a typical coronal mass ejection. This explains why Betelgeuse began a rapid decrease in October 2019 and by mid-February 2020 had lost roughly 3 times as much brightness, going from magnitude 0.5 to magnitude 1.7. By the 17th of February, 2020, Betelgeuse's brightness had been quite stable for more than a week. However, by day 5, it appeared that Betelgeuse had stopped dimming altogether, effectively ending the dimming event. Recent visual fading appeared to be unrelated to the imminent core collapse because there were no noteworthy changes in the infrared on February 24, 2020. Another study published on the same day concluded that large-grain circumstellar dust was likely to blame for the star's dimming. The study uses sub-millimeter wavelength measurements to rule out dust absorption as a major contributor. However, large star spots appear to be responsible for the dimming. A closer look showed that Betelgeuse's luminosity had dramatically increased. The recent substantial fall in Betelgeuse's brightness was linked to the discovery of a second dust cloud emerging from the star on August 30, 2020. A cold area on its photosphere was hypothesized to be the source of the dust in June of last year, and in August, a second independent examination confirmed the first. It is believed that the gas ejected by the star as it cooled created the dust. Obscuring dust may have been the result of a surface mass ejection, according to studies from the Hubble Space Telescope in 2022. millions of kilometers away from the star's surface. The material ejected from the star's surface cooled and compacted to become the star's waning dust. The star's photosphere, which is several times as massive as our moon, broke apart and sailed off into space, blocking it from Earth. The dimming, which began in late 2019 and lasted for a few months, was noticeable even to backyard stargazers. What's more incredible is that the supergiant's pulse rate has ceased after 400 days. In order to track this cycle, astronomers have been keeping track of Betelgeuse's surface motions and brightness variations for the past century or more. The force of the explosion is reflected in the damage. Astronomers have put out a theory that could account for the disturbance. The star's photosphere is also being rejuvenated, so it's gaining strength over time. The star's internal structure is vibrating like a shattered bell as its natural cycle is disturbed. These findings shed light on the process by which red stars age and lose mass before their nuclear fusion furnaces run dry and they explode as supernovae. What happens to them depends critically on how much mass they lose. The unusually malicious conduct of Betelgeuse does not portend the star's fast rise to prominence, so it's not always the case that a major loss event signals an oncoming explosion. Experts have stated that a large star's surface mass ejection has never been discovered, suggesting that there is something happening that we do not yet comprehend. Hubble can help us spot distinguishable surface features, such as the real-time observation of star formation, as we witness this hitherto unseen phenomenon for the first time. The ejected material's infrared radiation is still on its way away from the star, so it may be detected by NASA's James Webb Space Telescope. Finally, Betelgeuse's dimming has halted, and it may once again become the 10th brightest star in the night sky. Betelgeuse, despite its great distance, is one of the brightest stars in the sky, shining at almost 100,000 times the brightness of the sun. Keeping up with Betelgeuse's enormous energy demands rapid fuel combustion, which hastens the star's destruction. When the star runs out of fuel and collapses under its own weight, it will explode into a spectacular supernova. Then, for a period of several weeks to months, Betelgeuse will become extremely bright, perhaps approaching full moon levels. It will become obvious as the day progresses. If so, when can we expect it? We probably won't see that happen in our lives, but nobody knows for sure. It may happen tomorrow, or it could happen in a million years from now. Will Earth be destroyed by the Betelgeuse supernova? Since Betelgeuse is so far away from Earth, its explosion won't kill or even severely disrupt life here. According to astronomers, the safest distance from a supernova for human life is 50 light-years, making Betelgeuse over 10 times more distant. Instead, everyone on Earth will get a show when a very bright star suddenly appears in the sky. Please share your opinions in the comments. Thank you for watching this video until the end. If you like this video, like and subscribe to our channel for more like this. We have another very interesting video ready for you. Click on the video on your screen and let us take you into another incredible space adventure.